Okay, so the probability model below describes the number of repair calls that an appliance shop may receive during an hour. So then it has a little table there. How many calls should you expect per hour? So we have E of x is equal to, it's going to be the number of calls times the probability of each. So 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2. And that comes out to be 1.7 calls per hour. So then for standard deviation, well, we have to find the variance first. So variance is going to be what it was, so the number of repair calls minus the expected value squared times the probability. So 0 minus 1.7 squared times 0.1 plus 1 minus 1.7 squared times 0.3 plus 2 minus 1.7 squared times 0.4 plus 3 minus 1.7 squared times 0.2. And that's going to give you a variance of 0.81. And so standard deviation, we're taking the square root of that, which ends up being 0.9 calls. So based on that, find the mean number of repair calls the shop should expect in an 8-hour workday. Any ideas on how I should do that? Yeah, for how many calls they should expect in an 8-hour workday.
Oh, you can, I think, this is a hunch, but like, maybe you can just like add or subtract 0.9 from, like you added each hour, and then
That's the standard deviation.
just like the average.
No. The average is the expected value.
So, no, I don't.
So we have 1.7 calls per hour in an 8-hour workday. So I'm going to multiply 1.7 times 8. And so in an 8-hour workday, we would expect 13.6 calls. So then what is the standard deviation of the number of calls the shop should expect in an 8-hour workday?
We gotta find the variance first, right? Okay, so. And this is like calls per day, not calls per hour.
Per
Okay.
day, yeah,
Alright, so
for an 8-hour workday.
you can do basically what you've been doing, except 1.7, 13.6.
You already have variance. This is for 1 hour. So if I want it for 8 hours, what would I need to do?
Multiply by 8.
Yeah, so I'm going to multiply the variance 0.81 by 8, which is 6.48. Then I need standard deviation, so I can take the square root of that, which comes out to 2.55 calls. So for basically the work day, I would expect 13.6 calls for the day with a standard deviation of 2.55 calls. Gotta love that. All right, I'm gonna leave this one for you to do on your own. Because it's basically like the one we just did. So that way you can try it. But we'll do number 5. It'll just be one of your homework problems.
This one of my homework
The exam before will be one of your homework problems.
problem.
And then we can go over it, obviously, afterwards. All right, number 5. A company selling vegetable seeds in packets of 20 estimates that the mean number of seeds that will actually grow is 18 seeds with a standard deviation of 1.2 seeds. You buy 5 different seed packets. How many bad seeds do you expect to get? So how many bad seeds are in each packet? On average. 2. And then we bought 5 seed packets, so each multiply. So we would expect 10 bad seeds.
I was struggling because I didn't know. Because they didn't say nothing about bad seeds.
Well, yeah. I guess it should have said seeds that won't grow. How many would you expect? All right, so then what's the standard deviation for the seeds? Like for all of the...
So how would you find the variance?
Well, so variance, so we were given standard deviation, and standard deviation is the square root of variance. So we would square the standard deviation to get the variance initially. Because we can't just multiply this by 5, because if we do that, you're not allowed to do that with standard deviation. So we have to convert it first. So we would do variance is equal to 1.2 squared, which is like 1.44. Then we can multiply that by 5. And so the standard deviation would be the square root of 5 times 1.44. I don't even know what that number is. And then that comes out to be 2.68 seeds. So then what assumptions did you make about the seeds? Do you think that assumption is warranted?
Warranted?
Like, is it legit? Like, is that a good assumption to make, basically?
So what do you mean by like assumption? Like what do we?
Like what wasn't stated in the program or like in the question, but that you assume to be true about the question or about this particular topic?
So
Think like last section, like our last chapter.
I mean, I would think that like the seed was good to buy. That's only 2 bad seeds.
So, are they independent of each other?
You could just say that.
Well, no, that's like the answer.
Um,
So, assuming the seeds are independent of each other, there could be a bad batch of seeds. Where like none of them were to grow. So it is safe to assume they are independent. All right. The average time to complete the Boston Marathon is 3 hours and 22 minutes with a standard deviation of 24 minutes. The average time to complete the London Marathon is 2 hours and 57 minutes with a standard deviation of 20 minutes. If someone competes or completes both marathons, what time would you expect them to have?
So, isn't this kind of like the last part?
Kinda.
So it's 3 hours and 22 minutes. Standard deviation 24. Average time complete is 2 hours and 7 minutes. Standard deviation 20 minutes.
So for this one, I just want the expected time, which would be the average. The next question, I want standard deviation. So I want the total time to complete. How would I find that?
You would,
What would I do with the 2 times?
2 times.
If I want the total time to complete, what would I do with the 2 times?
I'm so lost.
First grade math.
But where you see 2 times at?
Huh?
Where you see 2 times at?
No, like there were 2 races.
Oh, I thought.
There's a Boston Marathon and a London
I thought you
Marathon.
meant like 2 times something. I know you're talking about like the 2. Like you could like tap your wrist or something. When you would just multiply or add them. Then you multiply. Add them.
Adam. I just want total time, so I'm just adding them. So 3 hours, 22 minutes, and then 2 hours, 57 minutes. So that's 5 hours and 79 minutes, which obviously I can convert that to another hour. So it'd be 6 hours and 19 minutes would be the total time. So then, how would I go about finding the standard deviation for the total time? What in the world are they doing? Like screeching.
You would multiply the total time for the variance. You multiply the total time by 2. The standard,
Multiply?
no. You would.
Am I allowed to add standard deviations together?
Yeah. No. How about that?
So what do I have to do to be able to do that? Again, freshman.
I hate it. Anyway, so in order to add the standard deviation, you gotta, I don't even know.
I need to change them to variances.
I was gonna say that.
So I'm going to square both of them. So 24 squared plus 20 squared. So then, I don't know what that ends up being off the top of my head. I think it's, anyways. The square root of that value is the square root of 976, which is, well, because we want standard deviation. This was variance, then this is the standard deviation. So 31.24 minutes. So then, on average, how much faster can a person run the London Marathon than the Boston Marathon?
So, order to use.
So this is literally like if it takes you 20 minutes to drive to school and it takes like on the interstate and it takes you 30 minutes to drive to school on the like on the other roads, like what is the difference in time? Like that's literally all we have to do. In 3 hours and 22 minutes.
This class might be overthink stuff. That's why I keep getting it wrong.
Mine is 2 hours and 57 minutes.
Because I could literally, like, it'll be one problem. And then I have to do a whole, like, 3 formulas in one problem. The very next problem is just simple addition.
So I'd have to convert this down to 2 hours, make this 82 minutes. So then 25 minutes. So what is the standard deviation of this difference?
So we have to square.
Okay, and then do what?
You got square. And then, yeah, square. And then, but square is square root.
Well, so the standard deviations are what you're given, so you would square it initially.
Alright, so you got square root and then that's your answer. Please just tell me what it is.
So we always add variances even when we are looking for the difference. So it would be the square root of 24 squared plus 20 squared, which is 31.24 minutes. So it's actually the same. I need to check something really quick on the calculator for this problem. I need to find something really quick because we can't do this next problem yet without that. wasn't able to find it when she looked.
She ain't text back yet.
Oh.
Cause you know like how names have meaning and stuff.
Yeah. All right. I'm gonna give you this because you're gonna need this for the next problem.
I will.
Huh.
I think Ethan is.
Mine, it depends on where you look it up.
I just look up on Google. What does Ethan mean?
I don't know. I had a plaque in my room that had like what my like name meant, like biblically or whatever.
Yeah, my name got I had my cousins.
I don't even remember what
When
mine is.
they were like babies, they had like their headboards had their name and what it meant.
I forgot. Mine means resurrected one. That's what it is. Makes no sense, but that's what it means.
That's what Stacy meant.
Apparently. I forgot. I had to do some project and I was like trying to remember what it was, but that's definitely what it was. I was like, I don't know. Okay. In the 4x100 medley relay event, 4 swimmers swim 100 yards, each using a different stroke. A college team preparing for the conference championship looks at the times their swimmers have posted and creates a model based on the following assumptions. The swimmers' performances are independent, and each swimmer's time follows a normal model. The mean and standard deviations of the times in seconds are shown below. What are the mean and standard deviation for the relay team's total time for this event? So, for the mean, we literally just add them all up. And that ends up being 200.57 seconds. So standard deviation, obviously we can't just add those values, so we need to turn them into variances. So I'm going to make another column over here for each one, and I'll write what it is. So you would just square each of these values that are given, and I already have them, so I'll just write what they are. So 0.0576, 0.0484, 0.0625, and 0.0441. So then to find the standard deviation for the total time, we're going to take the square root of all the variances added together. So it would be the square root of 0.0576 plus 0.0484 plus 0.0625 plus 0.0441. And that gives you 0.46 seconds. You just square the standard deviation. So it would just be that. So if you're given standard deviation, you always will just square it to get your variances. If you're given variance and you need standard deviation, you take the square root. So then the team's best time so far this season was 3 minutes, 19 seconds, and, you know, whatever the extra little 48 is. 199.48 seconds. Do you think the team is likely to swim faster than this at the conference championship? We have to do some math, but
Oh.
so there's a way, I'm just going to put it on here. There's a way you can do this thing with the z-score. So it would be what you're predicting or what you were predicting to happen. So the 199.48 minus your average, the 200.57, divided by the standard deviation 0.46. And that would give you a z-value. Then you get a fancy table and you have to go on there and see what it says it is and blah, 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 blah. I don't like that method because your calculator can do it for you. So basically, just so that you can see a visual of what we're looking at, we've got a mean value here in the middle of 200.57 from what we found up here for the total race. They want to know if they can basically get anything less than this, if they could do better than this. So we're going to take...
I remember this.
So then over here, we have the 199.48, and we want everything over here.
I remember asking you, how do I know which side? And you explained it like 7 different ways to me. One of them worked.
So then there's a function on your calculator called normal CDF.
Is this being recorded?
Yeah.
Why?
Well, in case Ethan needs to go back to it.
What happened?
They asked me why I was recording this. I record everything, so. So normal CDF of, and so it's gonna ask you for,
Oh, that's the one where it's like 3 values. It's one where you put the 3 values.
It's 4, but yeah.
It's 4.
So it's gonna ask you for a lower, an upper, a mean, and a standard deviation is what's gonna get put in. So for this problem specifically, for the lower, the calculator's always going to have a lower value in there. It's going to be like -1 e to the 99 because it's just, you want something that's just way smaller than what you need. If it asks for it in a specific range, then your lower is like the bottom number in your range and your upper is the higher number. But our upper is going to be 199.48. The mean is the 200.57, and the standard deviation is 0.46. So to get there, you're going to hit on the calculator second. Let me see, it's second. I think it's the VARS button. It gives you it's like distribution or something. And then you're looking for normal CDF, and then you type all that in.
Oof. I really do remember doing this, and I remember the sadness it made me feel. And then when you had more, and then, oh my goodness!
I ate like 10 earlier.
Flashback to when me and Sarah ate the whole bag. And when I mean me and Sarah, I mean me with a little bit of Sarah.
You can try to type that in and
I
make
just
sure it
want
works.
y'all all to know that I'm having a midlife crisis.
Again? Also, why is your balloon deflated?
Wow!
Let me see that
Ethan's
one.
balloon is doing great.
I
Are you
think
gonna
I'm
break
falling
your balloon?
apart.
Mm.
I am actually. Can you hear me now? I want it.
Is -1 E9 now always going to be the lower?
No, not always. Because sometimes we'll want the values on the other side of the graph.
Then what would it be?
So then you're lower, so let's say we wanted to know if it was going to take them longer than, we would put this value in as the lower, and then we would just put a really, really big, like 1 e to the 99, because then, that's way out in infinity, basically, would be your upper.
And beyond. Good, infinity.
What's yours supposed to be?
I have to go poop. I'll be back.
Let me know supportive.
Like 0.0089 or something. Okay.
Just she says that a lot.
Huh?
She
Oh.
says that a lot.
I thought you were talking about me. I was like, what?
No, you should say 0.009. A lot.
So this right here, this is less than 1%. So it's unlikely because the probability is less than 1% that they will be faster.
Oh my word, I remember doing this exact problem.
Well, it's in the example, so.
If the grammar mistakes count as cookie form,
No.
never mind.
Not an English person. For a reason.
I don't know. Why don't we do
I
that?
was say you know what apostrophe is.
Huh?
You know what apostrophe is. It's a contraction. So it's supposed to be it is.
I'll tell Miss Patton.
Go eat them. You know what's funny? I would have never noticed.
Math person for a reason.
No, what am I, just person?
I said I'm a math
I know, so
person
then
for
what am
a
I?
reason.
Just person. Because English, math. Well, you know how stats went. I did great. Like, I got good grades, but my comments.
All right. Mr. Stames likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, Mr. Stames adds 4 randomly selected packets of sugar. Suppose the amount of sugar in the packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What's the probability that Mr. Stames' tea tastes right?
I think we just decided that he was picky.
So we need to find the mean. We know for each packet, but he's putting 4 packets in there. So what would I do?
She proves.
Okay, there's someone in there. What are you doing? Swapping them?
Guys, there are classes going on. Please be quiet. Thank you.
Stacy.
That was
A little much.
Well, they're still being loud.
Correct.
Correct. Good job.
Anyway.
Well, I walked out in the hallway, and I was laughing by myself at y'all. And then Punch Charming walked out. And I was like, oh god, this is a very singular just did here laughing by myself.
Okay, Ethan, what is the mean of the 4 packets of sugar?
So it's 2.7. 2.17 times 4. So that's 8.68.
Did you do it in your head?
Yeah,
Oh my word, what are you, a calculator?
something like that.
Yeah.
Whoa! What's 2.17?
I'm always like, what is this multiplied? And he's like, boom. I'm like,
Hey, I don't
Wait,
want
what's
these.
2.17 times 5?
2.17 times 10.85.
Oh my word!
Yeah, 10.85.
I'll take the chocolate away. She doesn't want it.
Wow. It is 10.85.
How much you were in class with us?
okay, standard deviation. How do I find that? For the 4 packets. Why don't you rest your shoulder, hun?
You can't call me that anymore.
Why, hun?
It's sweetheart now.
It's a weird name, sweetheart now.
Boing.
Hope,
Boing.
Hope,
doing that?
shut your mouth.
I can't do that.
So would it just be, would you square the mean? Or square root the mean?
Not the mean.
Um,
I was given a standard deviation for each packet of 0.08.
Give me
square root, right?
Square it first.
Square. Oh yeah.
So it's going to be the square root of 0.08 squared times 4. I won't make you do that in your head. It's 0.16.
I bet you he could.
Well, I'm sure he could. I don't know about the square root part,
With
but
much ease.
can you take square roots in your head of things like that?
I can go up to like. Cause I learned a trick. So like, if I could do it quick, just give me like 2 minutes.
Okay.
Alright, so
Oh, this is exciting.
I learned this trick, right? So it's like that square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, and square root of 10, right? So you see that, right?
Uh-huh.
So 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. So you just skip count by 2 all the way down.
To take decimal square roots?
No, whole square roots.
Oh. Well, I know how to do those.
I'm not. I know. I can't do that.
I was like, you can do decimal square roots in your head?
No.
I swear, remember when Garrett would do that?
That is very interesting. I've
That
never
is
seen
so
that
cool.
before.
Wow, you're cool. He's smart. Maybe he didn't want to be in a class with me. He would for my dumb questions. They're pretty dumb. She's laughing because she knows it's true and she can't say no, they weren't.
All right, our mean was 8.68, so it's going in the middle. He wants his grams of sugar to be between 8.5 and 9.
Man, can you even taste tea at that point?
Well, for perspective, there's like 60-some grams of sugar in a 12-ounce soda.
Ugh. I wonder how much is in all these eggs that I've just devoured.
You can look on the back of the bag.
I don't know how many I've eaten.
So now we're going to do the normal CDF. We want it within a range, though, so now your lower is going to be the 8.5. Then the upper is going to be 9, mean of 8.68, standard deviation of 0.16.
22 per serving.
And in theory, this should come out to 0.85. So there's an 85% chance his tea tastes right.
Who analyzes their tea that much?
Like stats is point.
Thank you. What about that one, the hypothesis one that we were making fun of? What was that? Why were we making fun of it?